Lacquer paint is appealing on many levels. Aside from self-expression, people turn to lacquer when they're looking for a protective surface. And it's not just professional graphic artists who spray paint walls. Every year, German industry covers several million square meters of surface area with thousands of tons of lacquer. At the Faun Company, a manufacturer of waste disposal vehicles in Lower Saxony, workers treat more than 1,000 vehicles a year with lacquer, protecting them from corrosion. And at Lisega, a specialist for piping and boiler construction also located in Lower Saxony, several 100,000 components used to store and mount industrial piping are covered with a thin layer of lacquer for the same reason. The parts have to withstand temperature fluctuations ranging from -196 to +650 degrees Celsius, conditions found in power plants and large chemical plants. To conserve lacquer, the Faun waste disposal vehicle manufacturer relies on a very simple principle. The workmanship of every steel component is precisely monitored in what's known as a quality gate. Do the dimensions perfectly match the construction data? Do the welded seams meet the necessary quality requirements? Only the parts that pass this test continue on to the lacquering process. The quality control reduces waste, and that in turn requires less lacquer and ultimately cuts down on working hours. Another factor that's important for reducing the amount of lacquer is good pre-cleaning. At Faun, the bodies of waste disposal vehicles weighing up to 5 tons are prepared for lacquering. A blast cleaner is used to remove rust, cinder, and welding debris. A special turbine is contained in a 9-meter-high by 7-meter-wide chamber. At speeds of up to 300 kilometers an hour, the power cleaner blasts tiny steel particles onto the treated surface. To keep this purifying storm of steel contained within the chamber, heavy gates seal the room. The products made at Lisega are smaller in scale. Here, workers use a blasting gun to provide components with the required surface roughness. Ultimately, the workers aim to achieve optimal adhesion of the lacquer onto the surface, preventing future chipping. That saves working time spent touching up the finish. Whether by hand or in a large blast cleaning chamber, a thorough pre-treatment is considered an essential requirement for saving material in the lacquering process. At the Faun Company, the power-cleaned parts are given a first coat in a lacquering chamber. Here, the company uses what's called an electrostatic process. Workers apply a charge of 30,000 volts to the vehicle's base frame. That creates an electric field between the lacquer sprayer and the component. The electrostatic forces draw the lacquer onto the component's surface. As a result, less lacquer misses the target, avoiding overspray. There's another advantage to this process. Because of the electrostatic charge, there is a greater coating thickness along the edges. And that is precisely where most of the strain will occur. The process not only reduces lacquer use, but also strengthens the component's carrying capacity, thereby improving product quality. A prime coat is also applied to the individual components at Lisega. To achieve optimal hardening of the finish, workers apply what's known as a two-component lacquer. Inside a special unit, the workers fill hardener and lacquer into separate containers. In this two-component unit, or 2K, the hardener and lacquer are not mixed together by hand in a container, but rather blended automatically. A computer determines the correct amounts, depending on what properties the lacquer requires. Both components flow together through a valve in exactly the right proportion. That creates an optimal chemical reaction between the lacquer and hardener, ensuring the right properties of the protective layer. Another vital advantage: since the hardener is no longer mixed into the lacquer container, it doesn't have a chance to harden inside. And when the lacquering work is complete, no waste is left in the container, and that saves material. At Lizega, too, the base coat is applied inside a chamber. Here, the 2K unit provides a further advantage. After the lacquering, workers don't have to clean the entire unit with all the incoming hoses, but only the sections of hose between the sprayers and valves. That reduces the need for solvents. Found, too, reduces the need for solvents when applying the top coat. The maker of waste disposal vehicles uses a very special procedure. The lacquer is warmed up during the lacquering process. A heating coil around the hose warms the lacquer from the surrounding temperature of around 20 degrees to some 40 degrees Celsius. That makes the lacquer more fluid. As a result, the spray is fine enough without the use of solvents, and that allows optimal spraying of the components. In addition, the length of the hose is optimized in the lacquer chamber. That provides the necessary freedom to work without unnecessary hose lengths. As a result, no extra meters need to be rinsed after the work is done, and that once again saves on solvents. During cleanup, chemicals are collected in a barrel. This mixture of lacquer and solvent is then treated in a special distillation unit. Almost all of the solvent is recaptured and can then be used again. This unit is located in the paint storage room at the so-called lacquer store. The workers here make sure all the buckets are tightly sealed. That way, no solvent escapes into the air and the paint doesn't dry out. Simple measures like these also save a lot of material. At Lizega, the maker of piping support systems, the treated products vary in size and shape. That means the lacquers have to meet different requirements. Depending on the guidelines issued by the lacquer manufacturer, workers adjust the pressure of the spray gun. In addition, the size of the component determines the opening angle of the spray valve. If the component is small, an opening angle that is too large leads to excessive overspray, resulting in a loss of material. During the lacquering process, workers also try to find the perfect arm position. The spray jet should always hit the component at a right angle. The wrong spraying angle normally results in an irregular thickness of layers on the component. As a result, more lacquer than necessary is applied to some sections. That means the correct handling of the spray gun saves lacquer. The skill can be learned at special training sessions, and Lisega uses other procedures to save material as well. We use a water-based paint called hydro lacquer that meets our customers' corrosion protection requirements as well as visual and quality demands, just as well as solvent-containing lacquer, and that saves a lot of solvent. The workers test a component treated with water-soluble lacquer with a cross-cut. They slice a given pattern into the dried finish to determine if the lacquer still has enough adhesion after enduring many small incisions. The results are clear. The water-soluble lacquer adheres just as well as the solvent-based finish. There is enormous potential for saving materials used for lacquering. A simple quality control as work begins. Electrostatic lacquering. The use of 2K units and hot spraying. In addition, using the correct pressure, the right spray valve, and the right spraying angle can easily reduce the amount of material needed by around 1/3. That actually increases the quality of the product, making lacquer even more appealing than ever.